Changing between Cartesian and parametric. Okay? All right, so here's the first one. Find the Cartesian equation for the parametric equation x equals t squared minus 2t, y equals t plus 1, which is the first one that we've been talking about here. Now, Cartesian equation, that just means the xy, right? The xy equation. In other words, what we need to do here, the parametric has t, so to get the Cartesian equation, we need to eliminate the t. Here's how we do that. To find the Cartesian equation, we just went x and y equation, so we need to eliminate the t. Well, that's going to be easy. It's just kind of a substitution thing, really, because in this case, can I say subtract 1 there? I get y minus 1 equals t. What can I do with that? Plug it into the other one, right? Now I can take, this is what t equals in terms of y, and so I can plug that in the x equation. And if you want the expanded form of that, just FOIL that out. Y minus 1, y minus 1. Be y squared minus y plus 1. That would be minus 2y plus 2. So I get x equals y squared minus 4y plus 3. That's the Cartesian equation for this. Which, if you think about it, that's what we got, wasn't it? That was the first one we did. It was that sideways parabola. And that's what that would be if I graphed it either way. Okay? All right, so let's talk about this one. Is that okay? All right, find the same thing. Cartesian equation for x equals 4t minus 3, y equals the square root of t plus 2t. Find the Cartesian equation for this one. So what do we want to do? Eliminate t. How am I going to do that in this case? Well, in this case, won't it be easier to do the x one, solve the x one for t? It'd be a little harder to solve this one for t now, wouldn't it? Yeah, so we're going to solve the, it doesn't matter which one you do. Both ways will be perfectly, but sometimes one is easier than the other. They may both be difficult, but anyway, yeah, this one I'm going to solve this one solve the x for t. Well, it'll be x plus 3 equals 4t divided by 4. So x plus 3 divided by 4 equals the t. Now I've got this, I can substitute for t, can't I? Here and here. So it'd be y equals the square root of x plus 3 over 4 plus 2 times x plus 3 over 4. Simplify, see that'd be the square root of x plus 3 over the square root of 4, which is 2. And then the 2 will cancel into that, so I have x plus 3 over 2. And I can combine, I guess. You don't necessarily be able to do all this with every one of these, but anyway, this one. So we'll get square root x plus 3 plus x plus 3 over 2. Something like that. Not too bad. This next one goes like this. Give me a little more. All right, so eliminate, here's what they'll say. Eliminate the parameter to find the Cartesian equation. X equals e to the t plus t. Y equals e to the minus t. Any thoughts? Well, I think y looks easier to solve for t here, doesn't it? I think so. How do I solve y equals e to the minus t for t? Well, it's an e exponential equation. What do we do there? ln both sides. Take the ln of both sides, and then that allows us to bring the power down. Ln of e is 1, so I just have ln of y equals negative t, so just divide by negative 1. So negative ln of y equals t. And we could do some other things with that with the power log rules. But let's just leave it there for now. We will do something with it more in a second. Okay, so now what do I do? Well, now I've got t in terms of ln of y, so I can plug that in right here and right here. X equals e to the minus ln of y plus minus ln of y, or just minus ln of y. With me? Does that simplify any? I've got e to an ln, don't I? Well, I will have if I... one thing I could do is put that in as x to the negative 1 power. I mean y to the negative 1 power. What about e to the ln? Doesn't that cancel? So we got x equals y to the negative 1 minus ln of y. Or 1 over y minus ln of y. Okay? Is that all right? Not too bad so far. Okay. Well, let's go the other way. What if I want Cartesian equation in parametric form? It's usually pretty easy. Right? X equals y cubed minus y in parametric form. Which I would point out, first of all, usually when we're graphing this, this is one we don't handle a lot because it's a function in terms of y, right? X is in terms of y, which is perfectly fine, but we usually don't do those types of equations. But in parametric equations, it's not very difficult because here's how you do. Write this in parametric form. In other words, x equals y equals form. Well, what are we doing here? We're writing each part, x and y, in terms of a t equation. What if I said y was equal to t? What would x be? T cubed minus t? Yeah. Usually in parametric, to put it in parametric form, yeah, just choose one or the other. If you've got the Cartesian equation and you want it in parametric form, just choose one or the other, the one that's easiest, to plug in t for, because it'd be, plugging in x to be t it'd be hard to solve. This one's solved for x, so that's why I chose y to be t. That's all you do. Okay, pretty easy thing to do. Okay, which Another point is, on most graphing calculators, anymore they have all sorts, but one where you're usually graphing y in front, that'd be a hard one to graph because you couldn't solve for y. However, put it in parametric form, parametric mode, we can do that all day long, right? T cubed minus t equals t, so it's one application of it, I guess you might say. Okay, so what if change y equals x squared minus 2x minus 4 to parametric form? The roles are reversed there, aren't they? Which one's going to be my t, which is going to be t equals x, yeah. So x, the x equation is just going to be t, because then y would be t squared minus 2t minus 4. Okay. So that, in that way, it's pretty nice. Let me mention this one other one, too. To get the circle in parametric form, let's talk about that. Parametric form of a circle. Simplest. Form of it anyway. Notice this. We could solve for y and all that, but here's the easier way to do it. What if I said x was cosine t, y sine of t? Would that match up with this one? It would, because x squared plus y squared equals 1. Isn't that true about our parametrics there? Because what if I plug that in? That's cosine t plus sine squared t equals 1, which is a very popular theorem, or identity, I should say. Yeah, so to get... well, that would be the circle radius 1, centered 0, 0. How could I get, say, x squared plus y squared equals 4? Well, that's a circle radius 2. And so the way I get it there would be x 2 cosine t, y equals 2 sine t. Is the way you do that. So you just put your radius in front.